Nothing will stop Elon Musk's dream of colonizing Mars. There's no doubt about that. With this, let's find out in this video what Elon Musk's insane revelation about the engineering of SpaceX Raptor engines. Welcome to Elon Musk Era. Don't forget to like this video and subscribe to our channel to stay updated on our upcoming videos about Elon Musk, Tesla, SpaceX, and more. A terrible Raptor crisis is currently facing SpaceX, according to Elon Musk. It cannot be disputed, however, that it represents a technological peak that cannot be surpassed. The question is, how are they so effective, and why are they being referred to as the king of rocket engines? So now, let's take a look at SpaceX's Raptor engine, an engineering wonder of the world. A starship would be nothing without Raptor engines. With 11 million horsepower, SpaceX's Raptor will be able to provide kinetic energy to its spacecraft. Furthermore, engines weighing approximately 1.5 tons can produce the equivalent of 4 Hoover dams. Comparatively, the Bugatti Veyron has an engine that weighs half a ton, or a third as much, but can only produce 1,200 horsepower. In the combustion chamber of a Raptor, a combination of methane and oxygen burns at high enough temperatures to melt its walls at higher pressures than those found in a scuba cylinder. Additionally, the exhaust is emitted at speeds that are over 10 times faster than sound. Then, as for the wall, you may wonder why the wall does not melt as a result of some clever manipulation of the flow of gas to keep the flame from touching the walls. Furthermore, extremely cold fuel is also pumped through the walls as a further safeguard against melting. So what sets the SpaceX Raptor apart? As with most rockets, the Raptor engine expels gases rapidly enough to propel the spacecraft into orbit. Nonetheless, the Raptor's cleverly engineered design allows it to be a powerful rocket. Like other engines, its primary function is to burn chemical fuel to generate thrust. Although it makes use of the liquid oxygen and methane, which are generally unheard of in rocketry. In addition, its innovative design makes it a possible ace in the hole for SpaceX to explore not just Mars, but the solar system. Furthermore, there is no other rocket engine that can produce as much energy as the Raptor engine does out of liquid methane and liquid oxygen. When compared to other fuels such as kerosene, methane prevents deposits from forming in the engine, a phenomenon known as coking, while its lower cost allows it to be sold at a lower price. The full-flow staged combustion engine is an engine that is driven by a motor that is connected to a turbine using a pump, and a small amount of fuel is injected into the pre-burner first to get the process going. Moreover, the propellant normally expends some of its energy in the traditional open-cycle engine before the process starts. Despite this, Raptor will utilize every drop of propellant, giving it the highest efficiency of any rocket ever developed. And this fuel is burned by the Raptor at a high enough pressure that it can direct the fire from the pre-burner inside a combustion chamber where it is completely burned with other propellants. By putting all propellants in the engine through pre-burners, this can only be done in a way that only the Russians have been able to do before. Because of this, Raptor's pressure is much higher than Merlin's, about 3 times more to be precise. Further, this increased rocket engine pressure made it the highest pressure rocket engine ever, which also contributed to its larger thrust than the Merlin engine despite its comparable size. In addition, the technology that has enabled this powerful engine is what's called full-flow staged combustion, a concept that conventional aerospace players have considered all but impossible for many years. Even though the Soviet Union and the United States spent a great deal of time developing this technology, no engines equipped with this complex combustion system have been flown. However, just 6 years after Elon Musk revealed that SpaceX was developing the Raptor, they are completing the first flight-ready engine. Further, this full-flow staged combustion engine promises to extract the maximum amount of energy from its liquid propellants, which is why it's often considered the holy grail of rocketry. With this, it is worth trying to squeeze a few more percent of thrust out of the vehicle in an environment where every ounce counts. Even more so if you plan to put these new full-flow engines on the largest operational booster rocket and spacecraft in the world, like SpaceX. However, what makes full-flow staged combustion so much more efficient? it's not just the enhanced fuel efficiency that this system offers to this kind of design. As an example, seals between the turbine and the pump are less critical, since they don't need to prevent the pumped liquid from contamination. A further benefit is improved engine efficiency due to fuel and oxidizer entering the combustion chamber as gases, as opposed to conventional designs that spray them in as liquids. In addition to running cooler and at a lower temperature, the individual turbines of a full-flow staged combustion engine produce considerably less heat than that of a single turbine in an established rocket engine. As a result, the turbine impellers are less stressed and should last longer before they need to be replaced once they've been inspected. Moreover, considering the importance of reusability in SpaceX's vision, it is likely to be just as important as improved fuel efficiency. SpaceX's Raptor engine is designed with a large number of coaxial swirl injectors that allow propellants to be injected into the combustion chamber instead of using pintle injectors as it did for the previous Merlin rockets it manufactured for the Falcon line of launch vehicles. Finally, we'll get to see what kind of power it has. Further, as a result of the engine's successful testing, 330 bar of pressure was achieved without exploding, a world record for rocket. According to Musk, during a controlled burn, the main combustion chamber of an unspecified Raptor reached 330 bar, or 4,800 psi briefly, but remained intact after shutdown. Moreover, Raptor engines are miles ahead of rockets made by other manufacturers, as they are far more efficient than those made by other companies. Additionally, a Raptor's crown comes approximately 18 months after Elon Musk announced the engine had beat the Soviets' RD-270 engine with a higher sustained chamber pressure at approximately 257 bar compared to 255. Within a few days, the same Raptor achieved its highest operating pressure ever, climbing to 268 bar with the Russian RD-180 engine. Moreover, in the unlikely event that the Raptor can sustain chamber pressures up to 330 bars without damaging itself, SpaceX could have effectively increased Raptor's maximum thrust from around 200 metric tons to 225 metric tons, or 440,000 to 500,000 pound force. Then, a 10% increase in thrust may add between 5 and 10% to the payload carried by Starship and Super Heavy. Further, the Raptor has two variants, and these are the sea-level variant, which will power the lower stage of the Starship, while the Earth-level variant was optimized for conditions on Earth. Alternately, adding a vacuum to the upper stage will allow it to continue moving even after the booster has been disconnected. In addition to this, a larger nozzle skirt extension enables the vacuum version to deliver optimal performance in space. Then, putting the two side by side, it can be readily seen the difference in performance. Additionally, Elon Musk has just introduced a new design of the Raptor, which he describes as being more efficient and aesthetically pleasing than previous Raptor designs, which is the Raptor 2. Moreover, SpaceX's crewed Mars mission is expected sometime later this decade with the help of Raptor 2, and it is even considered that there are no engines that can match these capabilities. Moreover, SpaceX's website indicates that the Super Heavy was originally planned to offer 16 million pounds of thrust. Musk's comments suggest this figure could reach 17 million. Accordingly, the most powerful rocket ever flew was the Saturn V, which last flew in 1973 and generated only half of the 17 million horsepower. Thus, these absolute advantages make the SpaceX Raptor an excellent choice for the aerospace industry. Meanwhile, I believe that with Musk and his team's capabilities, SpaceX can get through the current Raptor crisis as soon as possible. Up to this point, SpaceX has launched Starlink satellites with its Falcon 9 rockets, but Musk explained that such rockets don't have the mass or volume needed for second-generation satellite deployment. With this, SpaceX's Starlink service, which Musk has discussed spinning off in an IPO, also relies on the success of the Raptor engine program for long-term financial stability. That's all for this video about Raptor engineering, and thank you for watching. If you would like to receive updates on Elon Musk and his companies, make sure you click the subscribe and bell button.